Marketing Operations Working Group session at IETF 122 in, where are we? Bangkok. The spiritual side of me wants to assess, is Warren Kumari with us in the room? Can anybody sense him? He's not here? Oh, that's too bad. So welcome to the second session of Grow. I personally am quite pleased with the setup that we had this meeting and last meeting, where we have two slots of 1 hour rather than one slot of 90 minutes. It seems that we're no longer struggling for agenda time, but it sort of neatly fits what the working group is producing and interested in, and what's available as time in this meeting. So I think for IETF 123, we'll continue this approach. But if you have any feedback on the approach, let me know. As we start, we have our note will, which means, in a nutshell, that we will commit to treating each other with respect and engage in debate based on arguments rather than based on personality. The letters are purposefully a little bit small to encourage you to go to the website and actually read the materials with attention. This is unexpected. Has everybody scanned the QR codes to indicate their presence at this meeting? They are, I think, at the microphones. Make sure to scan that you're in the room. And now we need a minute taker. Is there a volunteer in the room who would be happy to assist me and take some minutes as we go through this hour? If there's no volunteer, I will have to appoint a volunteer. Ben. Oh, Benno. Oh, Ben, you're so lucky. Benno, thank you for volunteering to take minutes. When you finalize them, please ship them over to growchairs@ietf.org, and we'll get them uploaded. Thursday, that's today. So I would like to invite Luc to the stage to present on Draft Lucenti Grow BMP offline. And let me pull up the slides for you. Thank you.
Did you realize that you made a typo?
No, absolutely not.
It doesn't matter.
Where's the typo?
Search for it. It's kind of funny. And in the meantime, I will, hi everyone, I'm Luc. I will present an update on the BMP offline draft that Paolo presented in Dublin last time for the first time. First of all, some diffs on the front matter. Colin joined as a co-author. He brings a wealth of knowledge on this topic, so I'm really happy that he was willing to join us. And the other big thing is that we retitled the document, and you will see in a little while why, because we actually changed the entire approach, so we also needed a different title. So unfortunately, we got rid of the misspelled Italian word. Sorry, Paolo. And from here on, we title this thing BMP State Summaries, and it might change in the future again as well. So I will go into our new approach, but first, short recap of what we had in the 0.0 as presented in Dublin. As we, I guess, all know in this room, BGP sessions, BMP sessions, they can be very long-lived. And there's crucial information at the beginning of the session that you will need to completely and correctly parse the stuff that comes in over that session, maybe weeks later. And this is cumbersome when you try to do things like store BMP messages, on disk in 5 or 50-minute intervals. Then there's information in this first interval that you would actually like to use in a later interval. If you have a more complex setup where you try to disseminate messages over a bus with a certain retention, and you have subscribers that only subscribe later on and miss the beginning of that stream, they lack the information they need. Or even simpler, you're implementing a station, a collector, something goes wrong, you just want to look what goes on in that stream, and you start TCP dumping, and you miss the crucial beginning again at the end of, or at the beginning of that session, making your life a bit harder. Ask me how I know. So in the 0-0 approach to solve this, we propose to introduce a new message type called the peer summary message. And it looked like this. It was basically one big message containing all the peer up notifications that had been sent over the wire for that BMP session. So that would contain all the information in the BGP opens that you need to correctly parse whatever came in after that. Now, when Paolo presented this in Dublin, most of the feedback we got in the room and on the list was like, hey, where are these messages produced? The text only mentions producing these types of messages on the station side, so to store it online or to send it onwards. But at least some of the people saw value in also keeping the option open to produce these types of messages on the exporting side. Again, I want to stress that in the text, we only had the station at the time. But in our new approach, we will, try to make messages that work for both generation on the exporting side and on the station side. But that's a big difference. Now, after Dublin, the co-authors met again, and we realized that if you want a complete state, we also need, in addition to the peer summary, the actual contents of the RIP. So the text only describes the peer summary. We need something else for that. Do we want to introduce a thing like a RIP summary? Would it be an even more gigantic message with more stuff in there? That felt wrong. So we decided to rethink the approach, right? Because what are we doing here? We are requiring 2 new message types to encapsulate stuff, resulting in very large PDUs. And we're basically doing something in a slightly different way. But we're doing something that we already do, right? This looks really like the initial sync of a BMP session. So instead of introducing those 2 new message types, we introduce one message type called a state summary. And the state summary is basically a collection of TLVs, of which one is mandatory, and that is the summary ID TLV that is also introduced in the 0.1 version. Using that TLV, we'll tie together that state summary, a bunch of peer ups, and a bunch of route messages. So visualizing that, we have the station on the right, the exporting side on the left, and we're doing basically what we do in the initial sync. We send a bunch of peer up notifications, which contain all the crucial state that we need to interpret what comes after. And we send a bunch of route monitoring messages. So anyone familiar with the protocol will say, hey, this looks like an initial sync. That's right. But we proceeded by this state summary thing that contains the mandatory TLV, the summary ID TLV, and some optional additional metadata describing the time the summary was created, who is the exporter, vendor, software version, that kind of thing. And we slap this new summary ID TLV on all the messages that are part of the summary, right? So every peer up notification and every route monitoring message gets the summary ID TLV that is also in the state summary, the purple box at the beginning. So what we did is we create this logical concept of a summary by reusing the message types that we already have, where the only difference is that we tie them together with this new TLV. And as in BMP v4, we enable all message types to carry TLVs. That allows us to do a couple of nice things, because if we ever need to add another message type to our logical concept of a summary, we can just smack on the summary ID TLV. Other pros are we, as I said, only introduce one new message type. We are quite flexible with in-band metadata, as we call it, time of export, vendors, version, IP addresses of the exporter, yada, yada, yada. And it's almost identical, at least on the wire, to the initial sync as we know it today. There are some open points, there's some discussion. I might be getting ahead of ourselves here, but a logical question that then arises, why or could we change the initial sync to a summary as well? There might be value in there, but that's, I guess, something we need to discuss. I guess more importantly at this point is, do we need to signal the end of a summary? Because now we have individual messages, right? I think this is a must-have. We could reuse EORs like we do in route monitorings, again, as we know it from the original RFC, but we also have other options. We could send another state summary message with, I guess, a special TLV or a flag saying, hey, this is the end of the summary, and then we can include TLVs that describe what should be in that summary. Think manifest like numbers. You should have received 12,000 IPv6 routes, whatever. Then the receiver or the consumer can check my summary is complete, right? And this might make sense over the wire from exporter to station, but it might even make more sense if you start storing messages and mixing up things on disk or on storage, and then later having to reconstruct a data set and figure out, do I have the complete view on things, right? At least now you have a way to verify that. Another thing is, this way you can signal from exporter to collector if you have to abort your synchronization operation that this actually happened. And you can give a reason in a TLV. So I guess the second option here is more flexible and might be very useful. So next steps, I guess at this point is, first we need to determine, is this a way forward? And is it actually a better way forward than the stuff we presented in 0.0? And the most important sub-question there is this feasible on the exporting side? Now, again, we also want to use this on the station side, right? This is not only generated on the exporting side, we also see use cases where the station creates these types of messages, either to forward it on a bus or to store it on disk. But we want those message types to be the same. We don't want to make station-specific message types or storage-specific message types. I already had a... is there a timer somewhere, by the way?
Yeah, you still have 2 minutes.
Okay, great. Thank you. I had an extensive talk already with Prasad. Thank you very much. I'm going to summarize 2 hours of talking into one bullet point. I'm sorry for that, but going over the RIP contents is expensive. I think that's a fair conclusion that I could draw from our conversation. And we might need to make parts of the summary optional. Like maybe you do want a summary that only contains the peer up notifications, not unlike what we presented in the 0.0. And if, anything, we need to clarify and motivate why or what the benefits would be if you would do this from the exporting side. Because we realize this is definitely not for free, and it's very easy to reason about these things coming from the collector side versus the exporting side. We do realize that. There is more in the draft. There is some discussion about what the summary ID could look like, what type of meta TLVs we are possibly interested in. Maxence already had some great ideas about that stuff, but I guess that's for a later session to dive into, because we first need to make sure that this is a way forward. And that's all I have.
Thank you so much. The microphone moves over to the esteemed Jeff Haas.
I'm not steamed at the moment. Two comments. So, we've had at least overlapping conversation, but I'll summarize the two things I think are relevant for the group here. Thing number one is that for some classes of summary, if you're just having a station pick up like the fresh updates, you don't need to re-summarize everything because they're just simply storing the updates in the wire. You don't have to worry about whether it's stateful or not. That's not the application that you're doing. So sometimes you want to have the full thing, sometimes you won't. For the times you do, the analogy I think we're looking for here is this is basically a route refresh for all of our feeds. We normally think about that for rib out only, but for each of the feeds, it's the same idea. And that's partially why I'd suggest we leverage the the end of rib for exactly the same behavior. It avoids us having to build completely separate machinery. We just basically poke the button and say, "No, you've restarted."
Yeah, I've heard similar comments in my discussion with Prasad already. So that's not really a surprise.
Hi, this is Prasad from Cisco. Luke, just one point I want to add, just for the benefit of the working group. Like Jeff said, we also discussed, it looks very similar to the BGP route refresh. So I think maybe we should look at the route refresh RFC and the enhanced route refresh RFC of how BGP does it, where there is a BORR, beginning of route refresh, end of route refresh, and there is no specific state added to the individual updates. That's how it works in the BGP world. In contrast to that, here we have state associated with the individual route months. So I think it's worth looking at it and then having a discussion if that makes sense. It'll be very beneficial if we decide to do this on the router to go that way, because that's something which is already existing on the router. Thank you.
Yep.
Small comment from my side as regular working group participant. One of the bullet points you put forward is whether there should be an end of data marker or not. I think if we look at other protocols, invariably people down the road realize that, oh, having a marker that indicates this was the end of the data is super helpful. So I would pursue that path.
Thank you.
Thank you. I'm excited to see where this work goes. This definitely strikes me as the type of project where iterative progress is made alongside implementation work to discover what is the most efficient way to encode things. So I encourage this small collective to continue the work and return at the next IETF. All right, let's move to the German-Dutch department. Tobias. I need to put up slides. Revoke slides.
The big advantage of being right after Dutch speaker is that I don't have to struggle with a microphone as usual.
There's the clicker. Take it away.
So we all are fully aware of the definition of insanity. It's doing the same thing over and over again, expecting a different outcome. So here I am. We have been talking about revisions to 7545, which is essentially what is in BCP 194. That has been going on for quite some time, and also two additional EDs, which are related to that. And this is by me and Nick Hilliard on the main thing, and Wolfgang Kreml on the terminology thing. So the plan from IETF 121. We want to do something about BCP 194. It should be short enough for policymakers to read, generic enough to be resilient against this like specific technology changing, because apparently there's this weird group of people regularly meeting to change like documents. It should be testable independent of implementation, and it should be published quick enough to prevent harm. So We had a relatively convoluted thing in the beginning. That was the -00. Then Nick joined the effort and we made it really, really short. So the main document is currently 4 pages. Always happy about reviews. If you can pick this one because that review will be done quickly. Anyway, the idea was we move this on quickly before things become laws, because people are also considering putting some things into other standards documents, which are in BCP 194, which might not be necessarily advantageous. So what happened on the main document? Basically nothing since 121. The main point of the main document was that it's basically waiting for 2 what I coined EDs, like eternal drafts, to be adopted, so that these can be referenced as documents under working group control and not personal submissions. And that is basically this document talking about terminology and routing, and the other document talking about technologies you can use to accomplish what the main document is recommending. So what are the next steps? Get those 2 documents adopted. There was an adoption call with, it seemed like people were otherwise occupied. There is definitely some editorial polishing that can be done to these documents, but after all, the idea for these documents is to be like staying around and being constantly updated. I'm currently holding back a lot of feedback I got because I want to submit a -00, because that's what would have been up for the call for adoption, and then implement that feedback in the -01. Question is, and that is what we actually should use most of the discussion time here, do we continue with this plan? Do we alter the plan? Do people like these documents? Do they not like them? Shall we just kick that out and try to move the main document forward without them? What are your thoughts?
So speaking as chair, about 2 months ago, I initiated a call for working group adoption to understand the working group's appetite to jointly work on this document. And the silence has been deafening. Like, the amount of emails in response to this thread nearly overloaded my mailbox. So I think there were a few reactions, all positive, no objections, but it's not a lot of reactions. So I think one path forward in a situation like this is I will remind the working group via the mailing list, like, hey, we have these 2 drafts that are part of a slightly bigger project to provide framing context for routing security terminology. And I'm sort of leaning towards if nobody objects in the next 2 weeks, then we proceed to adopt them as working group documents. But I would much more prefer to have tangible feedback from the working group. So be on the lookout at your mailboxes for a reminder on this one.
So 2 things to add. A, maybe you shouldn't run your mail server on an ESP32. Second, I do realize that those 2 documents are basically like doing a call for, like, I would like to do the dishes. Is anybody in? So I fully understand. I fully understand that the engagement is somewhat limited and being like, great that you do that. Let me put my plate there. But it would be nice if it would be like or documents and not, an individual dish cleaning effort.
Jeff, to Blaze's point, this is a service draft. This is helpful to the working group. You, as a chair, don't necessarily have to, ask anything other than, does anybody in the working group object to this? This is, I think, now number 3 document I've seen for definitions and a terminology document over this IETF. And this overlaps me having sent a question off the IDR chairs of, shall we draft somebody to do the same sort of thing? So it's valuable work. I would suggest just simply saying, if there's any objections, let us know.
I appreciate the feedback.
Hearing that there's also other documents, I had a very pleasant experience in CyberOps where somebody presented a document that wants to do authoritative language for RPKI, which I, of course, really appreciate because those are all parts you don't have to put into a descriptive document because somebody else is doing that work. But I think we still need like the more vague and the more non-RPKI parts somewhere collected.
Ben Madison, Work Online. I'm one of the people that failed utterly to respond to the working group last call, despite the reminders. My apologies.
Not last call, adoption.
Sorry, the working group adoption call.
Horse behind the cart.
That's where it's supposed to be, right? Okay. My general view on this approach hasn't changed. I think it's still the right approach to take. It's not going to, I mean, I think the group should be aware that it's not going to be sustainable if there aren't more hands getting dirty in this. But it does have to start somewhere. I've just had a quick read through version 4 of the main document, and I think that looks at least in good shape. One of the open questions that I recall from Dublin was how this approach interacts with the system for assigning BCP numbers, whether that could be done given that that thing is going to be referring eternally to internet drafts that hopefully are never allowed to expire. I don't know that we've ever received an answer to that question or even necessarily asked the right people. Do you know if there's been movement on that question?
Are you referring to living documents?
Or whatever we're calling that nowadays, yeah.
I think it's somewhere in the COVID filing cabinet.
Because the concern I have is obviously there is an existing BCP number, which we are trying to kind of override somehow. So it's not like we can just ignore that problem because, you know, it's 194, right?
Yeah.
So BCP 194 does have to die one way or another. How we kill it, it would be nice if we could reuse it and make this BCP 194, but short of that, that has to go away because it's not current and it's not best. It's just a practice.
Parts of it, like maybe not even practice, but so it's 194. Back to the question about like did we ask people? I still maintain my position from 121, which is basically like, well, we have that document, so we get it through working group last call, we ship it over there, and then they will be like, But that's essentially the only way how to actually get the authoritative answer if we are moving in the right way. And like, I'm not assuming that this will just be swallowed by them.
To clarify, I'm absolutely not suggesting that we block on that question. I'm just suggesting that we answer it at our earliest convenience.
Yeah, and I would argue that you know the forceful way of asking is the best way there.
QMA's Max Planck Institute for Informatics. I'd just like to remind the working group of the relatively obscure status that everyone seems to forget about of adopted for working group information only, which means a draft is never intended to be published as a final eternal document that's not edited, but it's something that the working group adopts for its own purposes.
Yes, but I think part of the appeal of leaving it as an adopted document is that it gives you two options. If you, after like 10 years, realize that for the past 5, it hasn't changed, and you just made those little keep alive edits, you can also just be like, well, maybe we can just ship it now.
A document can move out of adopted for working group information only, but it just means it doesn't expire. It's a document
no, the second thing is we want it to expire.
Oh, okay.
Because that is like a core feature of this, that if we stop working on this, the main document quite clearly says like the last non-expired version. And if there's none, well, then there is no guidance, because no guidance in these things is a lot better than mildly not so fresh guidance. You know, it's not like wine. It's not getting better with being stored in a basement for some time.
Fair point.
All right. I did send out 2 emails for the 2 drafts under discussion. So I do appreciate the comments at the microphone, which to me are indicative of positive. Rüdiger Volk.
Jeff
I
has
lost
that.
my train of thought. I was saying something super important and I got distracted.
Very last
Okay,
comment.
Jeff.
Has anybody talked to the RFC editor about this yet? Because one of the things that's in my mail to the IDR chairs is we're also looking to update the canonical abbreviations list and that sort of thing. The RFC editor, as part of their process, actually maintains some of this type of stuff. If they or Iana or somebody else is willing to maintain the magic list for us, we just bless what the terms are. That's another channel.
Yeah,
That's good feedback.
Like, would that be an author or chair action?
First
Thank
things
you.
first, we're going to get this adopted or not. And yeah. All right.
I'll just-
anything else?
Do I have time left?
You have like 1 minute, maybe minus 1 minute.
Yeah, no, not worth it.
All right. Thank you so much. Next up, I would like to invite you to the stage for source address validation deployment status. And let me share the slides. How do you pronounce your name?
Shuai Wang.
Shuai
Wang.
Wang.
Yeah. Good.
All right.
Thank you.
Here is your clicker.
Okay.
And thank you for being here. Take it away.
Okay. Thanks. Good afternoon, everyone. I'm Shuai Wang from Zhongguan Lab. Okay.
Yeah, perfect.
Okay. Today I'm gonna talk about our draft about source address validation deployment status. I have given some presentation about this work since IETF 118, but in subnet core group. And in this IETF meeting, we have got a draft including all the presentations before. So app spoofing is one of the long-standing security threats in the internet, and source address validation is very important for us to protect the network from IP spoofing attacks. And it can be characterized into outbound SAO and inbound SAO. For OSAO, the filtering is applied at the network edge to traffic coming from inside the customer network to the outside. And for ISAO, the filtering is applied at the network edge to traffic coming from the outside to the customer network. And the Manners Initiative considers IP spoofing as one of the most common routing threats. And so this is why we should give a presentation in the work group. And the Manners Initiative defines a recommended action to mitigate spoofing traffic, encouraging network operators to implement SAO for their own infrastructure and the end users and for any single home stop network customer networks. However, only 1.6% of the routed ASs participated in Manners, and not all Manners members follow this action to implement SAO for their networks. So there is a lack of comprehensive knowledge regarding the current status of SAO deployment across the internet security. As a result, this document aims to provide a more comprehensive view about the SAO deployment in the internet. It includes some measurement methods and the most comprehensive so far about the deployment status. I will I will briefly introduce the measurement methods. The first is OSAO. The most famous about SAO measurement is the KDS buffer. Actually, it works as follows. It deploys a client on host in the audited network, and so the client can actively generate and send the spoof packets to the outside of the audited network. In this way, it can measure the filtering depth and the filtering granularity. The filtering depth means that a client can incrementally set a TTL of the spoof packets, and thus its forwarding path can be learned in a way like traceroute. And for filtering granularity, a client can generate spoof packets with arbitrary IP addresses as its source addresses. If a client is installed within a network, the spoof packets may be blocked by the NAT devices. Only about half of ASs tested by the Kit Spoofer project in the last year were tested based on public addresses. In the same way, the Kit Spoofer can also be used to measure the deployment of ISL. And we will skip the second method because the third one is similar with the second one. For the DNAT destination NAT-based method, when matching DNAT rules, the DNAT devices changes packets destination to precise addresses, but leaves the source addresses unchanged. So this will generate a spoofed packet. The DNAT-based method can utilize various protocols, such as DNS, which is used in the proxy-based method. It can also use other protocols like NTP and TCP to trigger the audited network into sending spoof packets. It can also be used to measure the filtering depth and the filtering granularity. And the next is about ISL measurement method. The first one is the resolver-based method. The scanner first sends the DNS query with a forwarded IP address that belongs to the audited network to the DNS resolver in the audited network. So if the DNS resolver receives the spoofed DNS query, it will send another DNS query to our controlled authoritative DNS. Then the scanner will also send a non-spoofed DNS query. So in this way, by comparing the results of the spoofed query and the non-spoofed query, we can infer the deployment of ISL. The second one is a SMP v6 based method. The scanner sends SMP v6 packets with false source addresses to the target network, and it can use the rate limiting mechanism of SAMP v6 as an observer to check whether the spoofed packets are received. The third one is also similar, but it uses the incremental global IP ID value as an observer. And the first one is also similar because it uses pass MTU discovery-based protocol as an observer to check whether the spoofed packets are received. We will skip the introduction about the measurement method briefly, and we have more detail in our draft. We want to put more attention to in the deployment status about the results. In the last month, we used this method to measure self-deployment in the internet, and the results show that about 67% of the tested IPv4 ASs and 72% of the tested IPv6 ASs like any SL deployment. And the partial SL deployment is observed in about 30% of IPv4 and 23% of IPv6 IPv6 ASs. This suggests that these ASs deploy SL at their access network. And about 14% of IPv4 ASs and 17% of IPv4/24 prefixes demonstrate complete OSL deployment. Then about 91% of the tested IP addresses deploy OSL within 2 hops away from the endpoints, and the prefix length of /20 to /24 dominates OSL deployment. This prefix length corresponds to standard IPv4 allocation units for ASs. Hence, this REST OSAV is predominantly deployed at AS border interfaces. And about 41% of the network filter inbound spoofing packets at the /29 to /30 granularity. We think this suggests that SR is predominantly deployed in access networks. This is our hypothesis because we do not have a network to validate this phenomenon. So we also think for help, look for collaboration, so we can validate about this conclusion. And about the deployment in countries or regions, China, South Korea, and France have demonstrated higher OSAL deployment ratios, while Russia, Brazil, and India shows lower OSAL deployment ratios. For ISAL deployment remains limited in most regions, with South Korea, Chinese Taiwan, and Poland exhibiting more advanced ISAL deployment. We also compare between the ISAL and OSAL. For example, G Network, DigitalOcean, and Korea Telecom and China Telecom achieves over 90% OSAL deployment, and Changhua Telecom, Korea Telecom, Charter, and Comcast demonstrate a significantly higher ISAL deployment. We try to analyze the correlation between the deployment of OSAL and ISAL, and we found that about 10% of ASs that deploy ISAL also deploy OSAL, while only about 5% of ASs without ISAL deploy OSAL. And about 36% of ASs that deploy OSAL also deploy ISAL, while only 22% of ASs without OSAL they deploy ISAL. We try to analyze the impact of manners on the deployment of SAL, and we compare SAL deployment ratios between manners and non-manners networks. This includes both full and partial deployment. And we found that manners network demonstrate superior SAL deployment for OSAL, about 29% in manners networks versus 19% in non-manners networks. And for ISAL, the number is 73% versus 56%. This result indicates that also anti-spoofing is a recommended action. The manners participation improves some deployment across network configurations. Okay, I will stop here. And if you are interested in collaborating or have any suggestion on how we can enhance our measurement framework and or to validate our measurement results, please reach out to us. Okay, thanks.
Thank you so much.
Thank you.
Okay, we're 3 minutes behind schedule, so yeah, please reach out via email.
Okay, thanks.
Thank you so much. We next up have Wang for requirements for monitoring RPK-related processes on routers using BMP.
Hello, I'm Shuhe Wang, also from Zhongguancun Laboratory. I know my name is maybe really similar to the former speaker. Yeah, it's really confusing. So, okay, so today I'll be talking about our proposals on the requirements for monitoring RPK-related processes on routers using BMP. So this is actually from we actually put our efforts on refining the RPK rollout sets, and we want to test if our efforts could make effects, and we want to test it on the real routers on the production networks. But we found a problem that we can, with current monitoring protocol, we cannot precisely monitor if RPK has effectively take effects on the router. So we thought about we thought the idea that maybe we can raise overall requirements for the for networking groups to add support on the RPK related process. So for today's talk, I'll be first introducing what is the full life cycle of RPK related process on the router, and then I'll illustrate with our real working cases to demonstrate that this RPK related information is actually needed for monitoring. And finally, I'll wrap up with the systematic requirements to extend BMP for RPK. So first, what is the RPK journey on the router? And from our conclusion, we conclude that it starts with getting RPK data from the RPK cache or the relying party, in short, RP in short, via the RTR protocol. These caches will get data from RPK repositories and transfer the validated payload to the router. And then the router will enforce RPK related rules on the routers, which include the validation rule set, as well as the router's action towards those non-valid routes. And third, once the RPK is enabled, the router will execute RPK-related validation on each incoming route and assign a validation state to each route. And finally, the route selection will based on these validation states to make decisions whether to export them or drop them. But from our observations, we find that actually each single one of the steps needs to be monitored. And I'll show you why with our cases. So for the first case, which is related to the stage 1, we tested with the software router, FRR, and we found that when the RPK cache fails, actually the VRPs on the routers, they just don't get stale, and they will freeze in the state right before the failure happens. And no matter if the cache just stays down forever or it bounces back to normal, the VRPs will just stay freeze down. And we tweaked every RTR parameters on the router, but the results are still the same. Actually, we don't know if it is a problem in FRR or it could be a common problem for all hardware routers, but this is a reminder to us that the router also needs to know about the RTR connection details in real time, especially when there are problems in the RTR connection. And for the second case, it is also tested with FRR, and we found that when the RPK cache refreshes, and there will be new VRPs coming to the routers, and which may invalidate certain routes. And we found that the route map that is used to do the RPK filtering actually don't work properly. The filtering costs for the prefixes, which should be validated as invalid, they are actually treated as valid. And we can only correct this by manually reconfigure the peer sweeping table, and then the validation can go back to normal. And we don't know if it is just a problem in FRR or any other hardware routers could have the same issue, but this also reminds us that any renewed RPK-related routing policy or rules should be reported in time. So the third case is related to stage 3 and 4, and we pay special attention to invalid routes. Actually, there are various reasons for routes to get validated as invalid, and here we list 4 possible reasons. And actually, we have seen all the four reasons in the actual routes that we calculate from the actual routers. And so to keep short, we don't explain them here. You can, for the last 2 cases, you can refer to our another draft. I'll keep going on. So the operators, they may want to know why the routes get invalid, but when they log on the commonly used current routers today, they will only find the validation state of each route. There are no explaining context, or there are no matched VRPs to hint at why the route is invalid. So we think it is also necessary for the router to show not only the validation state, but also why such state of the routes should be reported. Okay, so now let's go back to VRP. Let's go back to BMP. BMP is a good route monitoring protocol, but its limitation is it doesn't natively support RPK, not its standard version or most of its popular current extensions. Also, I know that there are current proposals that has covered RPKI, but they only covered RPKI in a really limited and small content compared to their whole proposals. For example, there are drafts that extend BMP with rod path state or extend BMP with rod event, and RPKI invalid is one of the state of the event, but it is just a small item of them. And there are drafts that extend BMP will extend the statistical report message with the counts related to RPKI validation, but still, all of the proposal, all of the drafts, they are not specifically designed for RPKI, and they cannot systematically cover the full RPKI lifecycle that we have mentioned about. So in these requirements, we actually raise a very high level requirements for supporting RPKI in BMP. And each requirement is actually responds to each stage. So for the stage 1, monitoring the retrieval of RPKI data from caches, we require the BMP to always rapidly detect and respond to the faults of outage in cache connectivities. And this include monitoring for each connection, the connection parameters, the synchronization details, and the error metrics. And for the second requirements, we require the BMP to always convey the newest configuration of RPKI policy. And this will require the BMP to always convey for each pair the enablement status of RPKI validation and the validation rule sites, and the configured action for non-valid routes, which means the filtering, tagging, or any prior adjustment in the priority. And for the third requirements, which relates to the third stage, we require the BMP to always detail validation of routes using RPKI. And this is the twofold requirements. For per pair, we should require the BMP to always convey the statistical summaries of validation outcomes. And for per route, we require BMP to not only convey the validation state of each route, but also the specific reason for that state. This means that the message should include the relevant VRP or ASPIRE entries that leads to the validation states. And finally, for the fourth requirements, we require the BMP to always record the impact of RPKI validation on the routing decisions. And this requirement is particularly aimed at those interesting routes. And by interesting, I mean for the routes that are demoted due to RPKI or promoted due to RPKI. And the BMP should just convey all the information that could have information and have the correlation with those routes. So to conclude, we have proposed a set of requirements to enable BMP to support RPKI, and in our current structure, maybe we need a separate new message, new BMP message for each separate stage. But looking ahead, maybe a more unified BMP message type for RPKI monitoring alone is better for RPKI extension. And also additionally, we want to state that these requirements doesn't contradict with any existing RFCs or drafts, because we only recommend, and we want to, and actually here we want to listen some questions and suggestions from you. So that's it. Thank you for listening. Yeah.
We're super short on time, so if somebody has something really, really important to say, I don't know what this movement means. Oh, I was confused with the other signal.
Okay.
Thank you for this presentation. I would encourage the working group to continue the conversation via the mailing list, because I think you're touching upon a few super interesting points.
Okay, thank you.
I think some of it seems software defects in a particular implementation, but your reasoning on what BMP can do in this context is super interesting and worthy of more discussion. So thank you for your presentation.
Yeah, thank you. Anybody can contact me at the email list. Thank you.
And next up, we have our final presentation. Using BMP over quick connections. Task control, your clicker.
Hello, everyone. I'm Yisung Liu from China Mobile, and today I will present using the BMP over quick connection, and I will be half of my co-authors from Changwang, Thomas, and Paulo. This is a brief update introduction for the draft from the last IETF presentation. We have added 2 new multi-stream usage mode. Previously, this draft only used the peer mode allocation by the peer. And for this update, we have add 2 more mode. One is the stream allocated per Afi and Safi, and the second is adding the extra control stream. The second one is that we updated some text description and the reference. The third one, and we welcome John, the Paulo will join as a new co-author. Oh, I have next. I will provide the detail of the 3 mode. The first mode I have mentioned in last IETF. So the peer stream in the peer stream mode, and each stream is used to transmit the BMP message of the specified peers, and but for the peer insensitive message, like the initiation and the termination message, it must transmit for each stream. And this is a new mode. The second mode is the new. The second and the third mode is the new mode. And this mode is about the per Afi Safi stream without a control stream. And for this mode, we allocated the stream for per Afi and Safi, and the each stream corresponding to the different address family. And for the same as the peer stream, and for the initiation and the termination message, for the peer insensitive message, and each stream for this mode should transmit the message for the initiation and the termination. And for the other messages types, this listed there. For the routing monitoring a message, and because it contains the Afi Safi information, so it will transmit over the corresponding stream. So for the routing mirror and the status report message, because some of them contains the Afi Safi information, and some of not contain that information. So if contains, it will carry it over the corresponding stream. If not, it will be transmitted over any one of these streams. For the peer up notification message, because it contains the Afi Safi information, it should be transmitted over the corresponding specified the Afi Safi stream. But for the peer down notification, because it not contain the Afi Safi information, so it should be transmitted over that have transmitted the peer up notifications streams. Okay. That's all of the second mode, and the third mode is that the per Afi Safi stream with the control stream. For this mode, we allocated the control channel, and we assume the stream 0 is used to send the associated control information, including the initiation, termination, peer up notification, and peer down notification. So the function channel, will carry the relevant information for the specific peer or the Afi Safi. For all 3 types of the messages, like including the route monitoring, and the statistics report. And for one peer, this function channel will have two types. One type is the non per aphilosophy. Another type is the per aphilosophy. And the peer down notification will transmitted on the control channel, and when the peer down notification is transmitted, and the all of the functional channel will be closed. Here is the detailed use case for this process, and we assume router A will establish a quick connection with the server, and the router A, for the step one will establish the connection, and the step two will create the control channel. Let's assume the stream 0, and it will send the initiation message by the control channel, and then when the peer up, one peer up, it will send the peer up notification message for in the control channel, and then it will create two function channels, because this peer contains the IPv4 unicast address family. So it will create the non per aphilosophy function channel and IPv4 unicast function channel, and it will transmit the route monitoring and mirror and the statistics report message on this channel. And when the peer down, it will send the peer down notification in the control channel, and then and the function channel 1 and 2 will be closed, and at the end it will send the terminal message and close the quick connection. So that's all of the update of this draft. Thank you.
Thank you for your presentation.
Jeff, as on behalf of the BGP over Quick authors, thank you for your symmetry for adopting things from our draft. But I think you're getting some of the concepts inappropriately mapped for BMP. Our motivations for BGP to split the stuff onto the different channels were for resiliency, for address family purposes. In the case of BMP, you're more interested, I think, in actually having streams per peer, if you're going to actually do that. The other thing that I'm a little more concerned about, and I think you're on the right track. This, figuring out what you want to send on the streams is going to be most of the fun of using Quick. What I'm going to strongly suggest is spend a little bit of time thinking about how your client stations, of which you have somebody that's going to consume it in the room, will have opinions about how the data should be showing up and how many streams you're going to have to multiplex over. The challenge for having too many streams is that you're never going to make fast progress on any individual stream. So you're going to delay, like table convergence as an example, because even if you have a highly parallel receiver, the producer is probably not going to be the same level of parallel. So this is going to encourage you to probably put things onto fewer streams than you are projecting right now. But it's a good conversation as to what you actually do. Thank you.
Thank you.
All right, final comments, because we're a little bit over time.
Prasad from Cisco. I had some similar comments like Jeff. We also need to think about out of order messages. Maybe it will be good to think, because we seem to have many streams. That's one aspect to consider. And then, like Jeff said, we have to be careful on the number of streams we split this into and what we use it for. Yeah, thank you.
Thank you for your presentation. I encourage you to continue collaboration with your co-authors on understanding how exactly BMP benefits from Quick. So we're almost done. There's my spiritual sense has picked up the presence of Warren Komari in this room. I think other people can also feel his presence. Warren, would you please come to the stage for just a second? So I think Warren Komari has been our area director for the last 240 years, give or take.
240, 245.
It is truly amazing. I mean, the internet is only, what is it, 60 years old, but Warren was there right from the start with the Grow Working Group and shepherding us along. So I want to invite everybody to give a warm applause for Warren's services the last years. Speaking as chair, but not in really formal capacity, I have very much enjoyed collaborating with you. I always looked forward to your gentle reminders about agendas and the review you provided on helping internet drafts get published. So yeah, thank you.
Thank you. Well, thank you very much. And Grow has always been one of my favorite working groups. I realize I say that in many working group meetings, but I actually mean it here. But I said one of my favorites. I missed that you were in the audience.
Okay, so now that the this internship as area director was done, what is the next step? Are you
a very long nap?
Oh, okay. All right. This concludes the second Grow session at IETF 122. I will see you all hopefully in, I think it is Madrid, right? Yeah, okay.
Madrid in July.
Thank you all for attending.
Yeah, it's going to be fun. Well, not like, yeah, but outside.